Hey everyone, this is Miss Park. Today's topic is called function notation. Function notation. So you may have seen in some, I don't know, in the past, something that looks like this, an F with a little bracket and an X. So today we're going to learn what that means and how to use it. And function notation is a huge part of this course because we'll see it every time we talk about functions, and there are many different functions that we're going to learn about this year. So your comfort level with function notation is going to be one of the keys to success here. So to start, we're going to go back to the concept of relation or function, which is basically a relationship between two things, two variables, and the whole idea of a relationship having an input and an output. So you'll recall we had the fellow who was cutting lawns, and so his earnings were based on how many lawns he cut. So the number of lawns was the input. Then there was a calculation based on his whatever he was being paid, and then the output was his weekly earnings. So same thing. In equation form, you've seen something like this, y equals 2x plus 1. This x is the input, and the y is the output. And just as a quick review, this is a function because number one, y equals 2x plus 1 can be graphed as a straight line, and straight line will pass the vertical line test as long as they're not vertical. So that is a function. And also you could see that whatever x you choose to put into here, whatever x you choose to be the input, you can only calculate one y from that x. Okay, so what we say here is we say that y, we used to say y is dependent on x. So that's kind of a grade 9 word, dependent variable and independent variable. In grade 11, we say y is a function of x. And it means the same thing. It means that y can be calculated from x, from knowing x. So I will draw you here what's called a function machine. Okay, function machine, we'll call it f. I've seen a picture kind of like this. In comes x, that's your input, and out comes y. And that's your output. Okay, actually, I'll put my x over here. Okay, the x is over here is the input, goes into the function machine, and out comes y. What does the function machine do? It calculates the y from the relationship. Okay, so if we're going to write it in xy notation, so with x's and y's, we will write this. But if we're going to write it in function notation, we're going to use a different symbol. We're going to write it like this. Right? Same thing, but I've replaced the y with this f and the bracket x. And the box, it tells you that f with the bracket x is read as f of x or f at x. It means it's this function f evaluated at this value x. Okay, so what will be the value of it when I input something into here for x? Right, so f of x is the value of the function f at point x. Let's do some examples. So let's say, for example, I have f of x is 2x plus 3. Okay, so different from above. So I can evaluate f of 5. It means if I have a function machine that is doing 2x plus 3 and I feed it a 5, what is my output going to be? Right? Remember, x is your input. So if my input becomes 5, what will my output be? So my output will be whatever happens when you apply this function to the input. So it's going to be 2 times 5 plus 3. Right? So whatever the input is, in this case it's a 5, it's going to go 2 times that number plus 3. And that is going to be 13. So f of 5 is 13. Okay, what's f of 0? Well, that's going to be 2 times 0 plus 3. And that's 3. Right? What's f of negative 1/2? Well, 2 times negative 1/2 plus 3, which is negative 1 plus 3, which is 2. All right, so I'll give you another one. What is f of, just pick an animal here. What is f of giraffe? Okay, f of giraffe is going to be 2 giraffe plus 3. Okay, whatever the input is, it's going to be 2 of those plus 3. Okay, so by the way, I like to work with giraffes, sometimes fruit and stuff, so just get used to it. All right, so given g of x, so now they don't always have to be called f. We could use any letter over here to denote the function. So you have f of x. Okay, let's go g of x. This one is g of x is 3x squared. It says here we will see other letters used to denote functions, right? Anything you want. So 3x squared, so what's g of 1? Well, let's input a 1 into this function. So it's going to be 3 times 1 squared, which is 3 times just the 1. Remember, order of operations, only the 1 is squared, and that's 3. Okay, g of negative 3, same thing. We'll put the negative 3 as your input and figure that out. So that's going to be 3 times 9. Remember, just negative 3 is squared, and that's 27. And the input, just like it can be a giraffe, it could also be other algebra. So if negative 2t is going to be my input, then I'm going to have 3 times negative 2t squared. And I can simplify that. The negative 2t is squared, so I have 4t squared. And that's going to be 12t squared. All right? And I can put an algebra, but I can put an algebra that involves x's, right? Here's g of x plus 1. This is not necessarily the same x as this. All it's saying is that the input to the function, so the function is 3x squared, right? The input to the function machine is x plus 1. What's going to come out? Well, you know what this function machine does. It takes the input, it squares it, and then it multiplies that answer by 3. So that's what I'm going to do. I'm going to take the input, which is x plus 1, I'm going to square it, and then multiply that answer by 3. Right? All that happened is this item that's in the bracket becomes the input, so we're going to input it into this function. And now I'm going to have to expand and simplify. So this x plus 1 squared is x plus 1 times x plus 1. Okay? You simplify it, you can use the area model from our previous video, you can use FOIL, you can use whatever method makes sense to you. So this will be x squared plus x plus 1, which is 3 times x squared plus 2x plus 1, which is 3x squared plus 6x plus 3. All right, so that's all it is. You put the input and you simplify. Now question 2 goes backwards. Question 2 says this: if f of x is negative 10, so this is actually referring to the same f as question 1, this f. If f of x is negative 10, then what's x? What it's saying is, here's my function, this is f, so it's 2x plus 3. If the output is negative 10, then what went in? What was the input? Okay, it's asking the question backwards. So we can figure that out, because if the 2x plus 3 is going to equal to negative 10, then I can solve for x. So this is negative 10 minus 3, 2x is negative 13, x is negative 13 over 2. Right, so that's telling me what the input would be if I know the output. Right, let's do it again. This one's asking about g, so it's the same g as above. So if 3x squared, right, this is the same g as in question 1b. If 3x squared is equal to 9, I can solve for the x. Then x squared would equal to 3, and x would equal to, I take the square root of both sides, being very careful, because when I take the square root of both sides, I introduce a plus or minus. There's actually 2 answers here. So both of these inputs would give you an output of 9. Okay, and so that's the gist of function notation. Now there's a little bit more. Okay, and that I'm going to, so you have a little practice here. Question 3 is for you. It's for practice. I'm going to do a couple of them though myself here as an example, but I wanted to also show you this one. Remember how we said relations can be represented in different ways. You could have table of values, you could have a point, you could have an equation. Well, you can also have a graph, right? So what this picture is showing you is this line over here is the graph of f of x. And remember, all a graph is, it's actually labeled, but it's hard to see. It says f of x there. All a graph is a collection of points that would have been in a table of values, right? So whatever this line is, we don't know the equation. We could probably figure it out using our grade 9 skills to figure it out, but we don't need to, because question A says, what is f of 3? And remember what that is. It's asking, this is asking, what's the output if the input is equal to 3? Or in other words, what's the y if the x is 3? So we are going to look for a point that has an x coordinate of 3. And the question is, what will be the matching y of that point on the graph of f? So here's the graph of f. These are very terrible axes. There's one there, and there's one there. Very hard to read. Okay, it's like that. And so on the graph of f, on this line, we are looking for a point that has an x coordinate of 3. So I'm going to count over from the origin, 1, 2, 3, and let's go up to the line. And oh, look, I see a point right there. This here is the point 3, 5. Okay, so what's the y that matches up with x equals 3? 5. Okay, and that's what that means. Okay, let's do another one, and I'll leave you these ones over here. Let's do another one. This says 5 times f of negative 1. See, that f is not being multiplied by negative 1. This is just a notation that says a function applied to an input of negative 1. So this is going to be 5 times. Let's look for a point on the graph of f that has an x coordinate of negative 1. The graph of f is the line. So I'm going to start at the origin. I'm going to go to negative 1 and find a point on the line that has an x coordinate of negative 1. Oh, look, I found one. Okay, so here I have negative 1 and negative 3 is a point. Okay, so that's going to be 5 times negative 3. All right, so here's the point. Negative 1, negative 3 is the point. So when the x is negative 1, the matching y will be negative 3. Okay, so here we are. So it's 5 times negative 3, which is negative 15. That 5 on the outside just says multiply that answer that you get by 5. All right, this one's saying find your f of 2 and square that answer. Square the answer. Don't square the 2. The input is still 2. You get your answer for f of 2 and square that answer. All right, same thing similar with these guys. All right, now here's what I wanted to show you that's a little different. So when you look at these, I'm just going to go back up to Q3. Question 3 is not with graphs. It's back to the equation. So it's fairly simple to input the number into here and evaluate it, right? This one is asking us to use both functions. So find the value of this and also find the value of this. They're giving us the equations and then just add up the 2 answers. Right? E is the one I wanted to show you. What's happening here is this is called f of g of negative 1. I'm going to write it, f of g of negative 1. It is a function inside a function. It means they want to know what is the value of f at the point g of negative 1. But g of negative 1 also has a value. It's the value of g at the point negative 1. So what I'm going to do is I'm going to just take them one at a time. I'm going to leave that f outside, and I'm going to calculate how much is g of negative 1. You know what I'm going to do? I'm going to use square brackets because it's going to be one inside the other. Okay? G of negative 1 is what I get when I input negative 1 into the equation of g. So that's going to be 2 times negative 1 minus 3. That's why I use the square brackets. I'm going to simplify the inside. So 2 times negative 1 is negative 2, minus 3 is negative 5. Now I've got the value of the inside is negative 5, so now I want to find f of negative 5. Well, what's f? F of x is x squared plus 1. So f of negative 5 is going to be negative 5 squared plus 1. Right? Negative 5 is the giraffe. It's the input. And so that's going to be 25 plus 1, which is 26. Okay, so your practice is to finish off this sheet. All right, you've got all these questions here that you can do based off of my example. These questions here are going to use the graphs. So F is the line and G is the parabola. And this question 5 is using the graph only going backwards. So remember what going backwards means. It means that we're giving you the input and we're asking you, we're giving you the output and we're asking you what's the input. All right? So basically for this question, we're going to look for a point that is something negative 5 and find out what that something was. And it's going to be on the graph of F. All right, so hopefully you can figure that out. And as always, I will post the completed worksheet. Please try your best as much as you can and to not look at the solutions, but your final answers are given down there. So hopefully that'll be helpful, and please ask questions and comments. All right, thank you for watching. See you soon.